Chapter number 1, Metric Spaces. Before going into the definition of metric spaces, let me speak of the distance function. In calculus, we study different functions which are defined on the set of real numbers or the real line. At several occasions, we have to use the distance function. For example, we use the distance function in the limit processes. As an example, consider the continuity of the function f of x at the point x is equal to a, where a has been taken from the set of real numbers, or it is taken from a subinterval of real line. So, from the definition of continuity in calculus, we have this function f of x continuous at point x is equal to a if this limit holds, limit x approaches to a applied on f of x is equal to f of a. There is another definition of the continuity of a function, and that definition is called the epsilon delta definition. According to that definition, a function f of x is continuous at the point x is equal to a if for every epsilon greater than 0 there exists a number delta greater than 0 such that absolute value of f of x minus f of a is less than epsilon whenever 0 is less than or equal to absolute value of x minus a less than delta. So this definition is given in the courses of calculus when you study the continuity of a function. So here in this second definition, we have used the distance function twice. First, we have used it here. The absolute value of x minus a is actually the distance between the point x is on the set of real numbers, or it is on the real line. Let me say that x is here. Absolute value of x minus a is the distance between x and a. Let me say that a is here. Then the distance between this point and this point is absolute value of x minus a. And we can write it as, if we take the distance function as d, then it is applied on 2 points, x and a. So it is the function of two variables, x and a, where x and a, they both are taken from the set of real numbers or from the real line. Similarly, absolute value of f of x minus f of a is also the distance between f of x and f of a. So generally, when we are in calculus and when we are taking the distance function, if we take 2 points x and y from the set of real numbers, then we say that the distance function is given by d of x and y, and it is equal to absolute value of x minus y. Note that the distance function cannot be applied on single point, because whenever you are taking the distance, you must have 2 points. Therefore, the distance function is a function of two variables. So when we are in calculus, we study different functions defined on real line. But when we come in functional analysis, we have the functions defined on more general spaces. Let me call any one of the space as the space X. This space is an abstract set. It means that the nature of the elements of X is unspecified. Similarly, the distance function when we are in calculus is defined on real line. But the distance function when we come in functional analysis is defined on the space X. And the distance function in the functional analysis satisfies only a few of the most fundamental properties of the distance. And those properties are called the metric axioms. And these metric axioms will be given in the definition of the metric space. So let me move on to the definition of the metric space. In the first topic of section 1.1, we will study the definition of metric space. A metric space is a pair and this pair is X, D. And as we know that X is a space, X is a space, and D is the distance function on X. Distance function on X or defined on X. And this distance function is also called the metric. Also called metric on X. Such that for every, take 3 points from X, small y, and small z from X, such that this metric D satisfies the following 4 axioms called the metric axioms. Number 1 is called M1. The first axiom of metric is that D is real valued finite, that is, it should not be infinity, and non-negative. It should not be negative because it is satisfying the properties of distance, so the distance cannot be negative. In other words, we say that D is greater than or equal to 0, and since D is real valued, so we can write it as it has the domain X cross X, which denotes the set of ordered pairs of x, and it gives the results into the set of real numbers because it is real valued. This was the first property. The second property is M2, and it says that distance of x and y, if we take any 2 points x and y and we apply the distance on them, then this is 0 if and only if these 2 points were identical. So this is the important property. If you are asked in the case of set of real numbers to find the distance between a point 5 and another point, it is again 5. Then since these 2 points are at the same location, therefore there is no distance between them. The distance between them is 0. And the third property is called the symmetric or symmetry property. It says that distance between x and y is same as the distance between y and x. D of xy is equal to d of y and x. So in the case of real numbers, if you're asked to find the distance between 5 and 8, then this distance is equal to 8 minus 5 absolute value, which is equal to absolute value of 3, and it is equal to 3. Similarly, if you are asked to find the distance between 8 and 5, then this distance becomes absolute value of 5 minus 8, and this is equal to absolute value of minus 3, and according to the definition of absolute value, this is equal to again 3. So this was so simple to understand. The next property is very important property. The third property is called the symmetry property. The fourth and the last property is quite important, called the triangle inequality. It says that d of xy is less than or equal to d of xz plus d of zy. To understand this important property called the triangular inequality or triangle inequality simply. To understand this inequality, draw a triangle with the points. This point is x, this point is y, and the last point is z. Form a triangle, this one, with the vertices x, y, and z. This line from y to z is the distance d of y and z, definitely. Similarly, this line is the distance between x and z, while this line is the distance between x and y. Now apply a property of triangle that the length of any side of a triangle is always less than or equal to the sum of the lengths of other two sides. So this is the length of one side, and on the other hand we have the sum of the lengths of other two sides. So the length of one side of the triangle is always less than or equal to the length of sum of lengths of other two sides. So this was very simple and easy to understand. So these are four important axioms of the metric space which are necessary to be satisfied if the given space is a metric space. So this completes the concept of the metric space. Now we will generalize the triangle inequality. And we will get a generalized triangle inequality. First, instead of 3 points x, y, and z, we will choose 4 points x1, x2, x3, and x4. First, we have to form a triangle. So we have this triangle and apply the triangle inequality here. This line is the distance between x1 and x4. So from triangle inequality we have distance of x1 and x4 is less than or equal to the other two distances, distance of x1, x3 plus distance of x3 and x4. So this was quite obvious. Now move to the next triangle, which has the vertices x1, x2 and x3. That is this one. And in this triangle you can again apply the triangle inequality. So by applying the triangle inequality on this triangle, we have distance of x1 and x3 is less than or equal to the other two distances, that is distance of x1 and x2 plus distance of x2 and x3. So put this inequality right here. D of x1 and x3 is less than or equal to d of x1 x2 plus d of x2 x3. So by putting this inequality here, we have, instead of d of x1 x3, we can put it less than or equal to d of x1 x2 plus d of x2 x3, and write the final term d of x3 and x4 as it is d of x3 x4. So this was the triangle inequality for these 4 points. Now proceed further and go to the point xn. The last point is xn, and the point just behind it is xn minus 1. So you have a new triangle, this one. So if you apply the distance property, sorry, the triangle property here, then you have d of x1 to xn is less than or equal to, look into the triangle, it is less than or equal to d of x1 xn minus 1 d of x1 xn minus 1 plus d of the other distance is the distance between xn minus 1 and xn. And again you have to break down this one as you did for the case of x1 and x3, and you have to form another triangle, and at that triangle you have to apply the distance property, and you have to proceed further so that you will get this to be less than or equal to d of x1 x2 plus d of x2 x3 and up to so on to the final term is d of xn minus 1 and xn. So this formula is called the generalized triangle inequality. Hopefully you may have understood it quite clearly. It was quite obvious. We have proved this formula now. Now we will go to the more general concept. Consider a subspace of X. Let Y is a subspace of X. It means that Y is a proper subset of X. Now you have a metric D which is defined on X on its ordered pairs, and it gives its values in the real line. Apply this metric D on Y. So it means that now you are applying this metric D on the ordered pairs of Y, Y cross Y, and the results are again in the set of real numbers. This metric is the restriction of this metric because this was the greater metric and it is applied on the ordered pairs of the greater space X. But this metric is now restricted to the ordered pairs of the subspace of X, and this metric is called the restriction of this matrix is this metric D, and we will denote it by D bar. So D bar is equal to the distance function or the metric D on X, but it is now restricted to the ordered pairs of the subspace X. And we call this new metric D bar as D bar is called the metric induced in inverted commas, this metric is induced on Y, because now this D bar is being applied on Y. And who is inducing this metric? The metric D is inducing it on Y. So this was our first lecture. In the next lecture, I will give you the examples of the metric spaces by proving all of the 4 properties of the metric. Thanks for watching.